ओके एवरीबडी बैक आ गए सभी लोग. Right? Okay, see, so this chapter is the total full name is reliability and maintenance, right? So both we are going to discuss what is reliability, what is maintenance, everything clear है. तो first of all what is reliability, correct? Reliability है क्या, जरा वो देखते हैं. तो reliability is, suppose I am telling this pen is reliable, it means it will not fail or the failing probability is very less, right? So reliability is the probability that a product will perform a required functions under a specified conditions for a certain period of time. Means this is a probability. That is why reliability, you will see its value is between 0 to 1. Getting my point? So what is reliability? Reliability means the probability, correct? Probability of working this pen for a particular time interval, correct, in a specific condition, right? That is reliability, right? That is why its value is between 0 to 1. Very simple. Or in negative sentence, what we can say, the reliability is basically probability of correct non-failure of any product for a specific period of time. That is also reliability. Means either you can say it is working probability for a particular time, particular condition, or you can say non-failure probability. Both are correct, right? So that is the case. Now I will explain few things. First of all, see, in planning stage only, this is also there in your book, no need to write, just listen carefully. In planning stage only, there are 3 phases. The first stage is called as operational quality planning process, in which QFD, I have explained you, Taguchi method. So both the methods we will apply and we will finalize the specification. Then the second stage is designing for human factor, that is Poka-Yoke and all, error proofing, you can remember, and also ergonomics. What is ergonomics? In design drawing safety, this will come ergonomics, but in simple word, ergonomics is designing a process or product in a manner so that it will not affect your health or employee health or users health. Getting my point? So that is related to ergonomics. So this by QFD and Taguchi we will finalize the specification, then we'll design the process or product in such a manner there will be no chances of human error, as well as there will be no adverse effect on health also by working in that industry, by working with that process, right? Okay, now the third stage is designing for reliability. So we are here in this chapter, we are here. So actually while designing for reliability, we have 3 phases. One is called as reliability apportionment, then reliability prediction, and then reliability analysis. So sir, what is reliability apportionment? The reliability apportionment is whenever you are designing a product, in that product there are different processes or there are different parts. So how much reliable should be that particular part is? So that thing you have to relocate and divide it in apportionment phase. Just I am giving you an example. Suppose in your industry you are designing or you are manufacturing a fan. Yes. So for fan, right, there are different components like their motor is there, yes sir, their shaft is there, yes sir, and their blade is there, casing is there, right, winding is there, so many things are there. So what should be the reliability of these all component? Means on higher side or on medium side or on lower side. So this kind of division is called as reliability apportionment. Very simple. So suppose motor is very important, so it should be highly reliable, means 0.9 reliability should be there, correct? So similarly, suppose blade, okay, fine, so 0.4 is okay, we can work with 0.4 reliability also. Like that, this division is called as reliability apportionment, correct? I'm explaining each thing from planning stage only, then we will come to maintenance in this chapter, but try to relate the point, correct? Whenever, see, one line is very important, that line is reliability, or what you can say, the maintenance is the result of design. Means a designer knows exactly after how many days or after how many months this product will have failure, correct? So that is why, as per failure probability, there should be a maintenance program. Very simple, yes. So that is why whenever in design stage you are, or planning stage, when you are talking about the design, you have to classify the reliability what a part should have. That is called as reliability apportionment. Now you can ask ki sir, each and every component should have high reliability na sir? Yes. So each and every component, if you will provide with high reliability, my dear student, then the cost will increase. And if the cost will increase up to a certain value, then value will decrease and no one will buy that fan, correct? Then, so there is a loss. So point is reliability apportionment. Then come to the reliability prediction. This is a simple mathematical calculation. One formula I will derive. From that formula, I will prove reliability is e power minus lambda t. Okay, I will prove it, don't worry. Then reliability analysis. What is this? See, after prediction, mathematically you will calculate ki which component is having failure probability after how many days. By this formula we will able to calculate. Sir, how sir? I will explain. I will do calculations. I will solve problems. Just wait. Okay, so sir, we are able to calculate after these many days we will have failure probability, or we will have failure, correct, in that component. So in reliability analysis, correct, we have to identify the weak points of the design. And once we have identified the weak points, now the required action and responsibility for the reliability improvement has been done in reliability analysis. This is called as FMEA or FMECA. This F means failure, M means mode, E means effect, A means analysis. So failure mode effect analysis, or in many countries it is called as failure mode effect and criticality analysis. So C for criticality, correct? If you want to write, you can write it failure mode effect analysis or failure mode effect and criticality analysis, right? So this analysis, correct, we find the weak point and we improve them, right? We improve them in design phase only. And if we are able to improve them in the design phase, then of course there is no need of maintenance. Take example of iPhone. So what they do after designing, they do FMEA, and in FMEA they find the weak point and again improve it. Just by improving, there is no need of maintenance. Very simple, right? So in concurrent engineering, if you can remember chapter number 1 and 2, two tools are there, QFD and FMEA. So QFD I have explained you in TQM and FMEA here only, right? Sir, how it is done, sir? So reliability improvement, I will explain how it is done. We will solve numerical also, right? Okay. So I hope you got it. There are 3 phases for reliability. Reliability apportionment means to divide all the components, how much reliability should be. Reliability prediction, that is a mathematical calculation, and reliability analysis, that is to find the weak point and improvement of those weak point, correct? अच्छा, ये है planning का part. This we are doing in planning stage only. So now sir, what we have to study in this chapter, sir? Yes, so what we have to study in this chapter is basically what is reliability, what is maintenance, types of maintenance, how reliability can be improved, like that each and everything will be there. Okay sir, so now right, first of all I will explain what is reliability prediction, means that formula of reliability, correct? So see here, you can also write it down, लिख सकते हैं आप, right? See, first of all, one thing is important, my dear friend, right? See, to define reliability, what we have to do is we have to first of all understand the failure probability, because reliability is defined by failure probability only. Okay, so suppose and one more thing, whatever kind of derivation or whatever kind of thing I am going to explain, you need not to remember all those things. You need to remember the result. But why I am explaining, so that you can correlate the thing, ki what we are doing, right? So failure probability function, failure probability distribution function इससे अच्छा जरा बोर्ड पे चलते हैं, ये इनका अच्छा नहीं है. Yes. So tomorrow schedule, first of all, if we are able to complete it today, then only tomorrow schedule will be something different. Otherwise, the same subject will be going on, correct? But still, tomorrow schedule must be known, correct? So, okay, I will find it. First of all, write down, then we'll discuss tomorrow schedule, right? See, what I want to tell you, we are going to discuss first of all reliability prediction. This is called as reliability prediction or reliability, right? Using mathematical calculation. So the failure probability distribution function is lambda e power minus lambda t. Exponential distribution you are using, correct? Exponential distribution, you can see. So here, what is lambda, sir? Lambda is failure rate. What is failure rate, sir? It is number of failure divided by time. Means particular time mein how many failures are there. That is lambda. Okay, sir. So that is the failure probability distribution function. Like binomial distribution is there, right? Exponential distribution, Weibull distribution is there, many distribution is there. That Gaussian distribution was there. Similarly, one exponential distribution is there, that is called as failure probability distribution function. You need not to remember these all things, but what you have to remember, I will give you, just try to relate the thing first. So now, this is your failure probability distribution function, correct, where lambda is failure rate, number of failure divided by time. Okay, sir. So here we will treat this as constant. So now question is, sir, number of failure, how it is fixed, sir? It can be vary, na, sir? Yes. So it is constant in a particular time phase, and that is called as useful life phase. Sir, what is that useful life phase, sir? So I will explain it later by bathtub curve. Now listen carefully. So this is this is the assumption, right? What is assumption? Assumption is we have to treat it as a constant. ठीक है? Correct. Sir, कैसे होता है? I will explain it later. Now listen first of all. So this is the failure probability distribution function. So now suppose we need to calculate probability of failure in a particular time t, assume it. So what is this? So this is just integrate that function, right, for that particular time. Okay, sir. So now what is reliability? See everybody, what is reliability? So reliability is 1 minus failure probability. 1 minus failure. Suppose this is the ft, so 1 minus ft. Very simple. So 1 minus 0 to t lambda e power minus lambda t dt. So this integral will give you reliability. Sir, what is that? So it will come as e power minus lambda t. So what is your duty? Your duty is to remember this thing only. What is reliability and what is lambda? Getting my point? Only this thing is important for you. But why I have explained it? Because at least you must know reliability. What is reliability? Reliability is nothing but 1 minus failure probability. 1 minus failure probability for a particular time interval. Getting my point? That is reliability. That is the definition of reliability, right? So first of all, do one thing, write down it in notes or on book, whatever you want, right? Write down fastly. Right, everybody? So I repeat, these everything you need not to memorize. That mathematical prediction is done by this method. What you have to understand, what is lambda and what is reliability, e power minus lambda t. That's it, correct? And lambda we will take it as constant. ठीक है, clear है? Yes sir. चलिए अब हम वापस चलेंगे. Now see, so whatever I have explained you, that is in book also, but not mathematically that much because that is not needed. So now see, reliability prediction using the exponential distribution. See, in your book also this is mentioned, correct? And that graphical representation is actually called as bathtub, correct? That is called as bathtub curve or bathtub, correct? What is it? See, the formula is given. What is reliability? E power minus lambda t. So first of all I will explain in bathtub curve, right? These thing already I have given you, right? Lambda already I have told you. Yes, see, in your book also this is mentioned. Come to this diagram, आ जाइए यहाँ पे, correct? Now see, here failure rate is there. Failure rate, what is failure rate? Sir, lambda sir. अच्छा, ठीक बात है. So lambda is there. And here time is, operating time of equipment is there. Yes or no? Yes. Now see whether lambda is constant or variable. sir, lambda is varying, sir. Here it is varying, then constant, and then again varying. Yes or no? Yes. So in this phase, lambda is variable. In this phase also lambda is variable. And up to here, what is lambda? Lambda remains constant. Yes or no? Yes. So actually this is called as useful life phase. Means whenever we buy a product, we buy at this point, my dear student, right? Here, this is time is equal to 0 for customer. And this is the durability, or what you can say, the lifetime of product, what is given by company, right? Suppose I have purchased this and they are telling me ki sir 3 year is the lifetime. It means after 3 year, correct, again this will be present with me. But point is, why company is telling 3 year? Because after 3 year again it will enter into wear out phase, where lambda becomes variable, failure will increase, and more maintenance is needed. That is why company already provide us what is the lifetime, what is the durability of the product. Getting my point? And whatever calculation has been done by reliability prediction using exponential distribution is done in this phase only. Correct? Means lambda remains constant. Now come to this phase. This is wear out phase. Already you know what is wear out phase. Means after their duration, after their lifetime, the product is, if still working, then you have to give a lot of maintenance. Similarly here, this is run-in phase. Run-in phase, or this is also called as infant mortality phase. Correct? Means when we get product, any product, before that there are many processes, correct, which was done on that product. Means whenever it is converted into raw material to product form, the failure rate is higher. That is called as run-in phase. Yes or no? Yes. In a example also, I generally give this example, and in this chapter I will give example related to human body also, so you can relate the thing, because human body is also like a machine only. The only thing is, in this machine there is a life also, correct, soul also, right? Otherwise this is a machine. We can replace, suppose there is a problem, replace it. Even heart replacement is there, right? So like that, like machine only, we give maintenance to body also, right? So see, after a certain time, correct, after a certain time we can fill the form, we can do the job, but up to that time, what is there? Just there is a growth time, there is a development time for this body. That is actually run-in phase. But after some time, 18 year or 21 year, now government will recognize ki yes, you are able to join the any job or anything. Yes or no? Yes. So that is this timing. But before that, failure rate is more, because body is in the growing stage. Getting my point? So that is also called as your infant mortality phase or run-in phase. Means when this body is in infant form, starting phase, suppose this is the, so at that phase also the failure rate, the mortality rate is more, correct? That is why we do a lot of maintenance, a lot of care to infant, correct? Suppose I am having fever, no problem, just take medicine, or will not take, okay. But if an infant is having fever, we will have to take care of that properly. Means more and more maintenance is needed. So my dear student, out of these three phases, correct? ये कौन सा phase है? ये just after retirement. So this is the retirement line, 60 years suppose. So suppose 18 year से लेकर के, correct, up from 18 to 60 year, this is your useful life phase, right? Just I am relating the things with product also, with body also. After 60 year again government will give retirement na, कि just take rest and stay at home, because कभी भी कहीं भी मेंटेनेंस की जरूरत पड़ सकती है. Yes or no? You need maintenance at any time. So that is why better stay at home, take rest. Yes or no? So that is your wear out phase. Correct? Okay, sir. Now point is where the maintenance we need more maintenance. So in material, in equipment, run in phase needs more maintenance because here the failure chance is more. So now you can ask, sir, here also na failure chance is more. Yes, but already that equipment has done the things, so now there is no benefit of giving so much maintenance. This is not applicable for human. Human is having emotional also. तो हम ये नहीं बोलेंगे बुढ़े आदमी को ज़्यादा केयर और मेंटेनेंस नहीं देना है फिर तो चाइना हो जाएंगे. करेक्ट नहीं, हमारे यहाँ होता है, हम लोग रिस्पेक्ट देंगे, केयर देंगे क्योंकि इमोशन है. बट द पॉइंट इज फॉर इक्विपमेंट नाउ वी नीड नॉट टू वरी अबाउट दिस फेस, बट वी आर वरी अबाउट दिस फेस. दिस इज आवर just manufacturing stage, run in phase. I hope you got it, and whatever mathematical calculation is there, that is actually done in this phase only where lambda remains constant. Clear है? एक मिनट वेट कर लो. If you want to write, you can write it. Just आपका थोड़ा schedule discuss कर लेता हूँ. If you can write something, you can write, otherwise it is written over there. Okay, so actually I was talking about your schedule because I think tomorrow also I need few hours, correct? So that is why I am not in hurry, correct? I will explain each and everything first, then I will complete. So tomorrow again I will take class, correct? But tomorrow no problem. I think 1 or 2 hours is sufficient, correct? So okay, fine. So see here, I hope you have got this point. अच्छे से समझ में आ गया. There are 3 phases, right? This is the useful life phase where lambda remains constant. So whatever reliability analysis we are doing, whatever that formula is e power minus lambda t, we are applying for reliability for this phase only, right everybody? ठीक है? ओके, बैटरी चेंज कर देता हूँ. Okay, done. I hope, right? चलिए, now, right? So reliability prediction using the exponential distribution will be just that graphical representation with a bathtub curve. So they will ask you, bathtub curve represents on y-axis what is their x-axis, what is their, correct? Like that they can ask question from bathtub curve. What is reliability formula, e power minus lambda t, like that they will ask. Okay, now see, something is called as some time basically is called as figure of merit. What is figure of merit? Try to understand. Figure of merit means whenever you want to buy, correct, whenever you want to buy any equipment or machines for your plant, then the point is you will ask first of all कि tell me what is the average time after which failure can occur, failure may occur, because designer already has done all the reliability predictions and all, so they know what is the probability of failure after these many time, after these hours, after these days. Getting my point? So your first question is, after on an average, after correct, how many hours failure will occur, right? So that is called as mean time to failure. First of all, why mean? Everywhere you can see mean. Mean means average we are taking, because we cannot do prediction for single product. Whatever we have discussing, that is for population of product, correct? For entire product, not for single product. Getting my point? Right. So this is the mean time to failure, means after how many hours the equipment is likely to fail. Getting my point? So first of all, this is applicable for non-repairable item. Non-repairable item means only one failure will be there for that item, correct? But the point is, suppose repairable item is there and then I need to calculate mean time to failure, then what should be done? So for repairable item, my dear student, I repeat, for repairable item, correct, first failure time we have to take. First failure time means the first failure after how many hours it is occurring, correct? So in note only, in book also it is written, see in bracket, what is failure time for repairable item. So for repairable item, the first failure time we have to take, correct? And then we need to take average of all the items, all the failure time, correct? Because we are discussing for population of product, not for a single product. Now come to what is mean time to repair. See, the name repair means, suppose one failure occurred in this pen. So how much time it will take to restore it again in the previous condition? Repair, already you know what is repair, usko ठीक करना, right? So again, why mean, sir? Because there are many repair work. Many repair means, suppose first failure T1 time it has taken, second failure T2 time it has taken, third failure T3 time it has taken. So what we have to do? We have to take average of all, and that is divided by number of failure. So that is called as mean time to repair. So now tell me why these are figure of merit. Because suppose failure time to failure, mean time to failure is large, means after 1000 hour failure is coming. So it is good for you, for equipment, your plant. Then you want to buy that product. Getting my point? That is why this is called as figure of merit. Suppose mean time to repair means time to restore it, correct? उसको ठीक करने में जो time लग रहा है, suppose it is less, very less, means in 1 hour you can repair the machine. It means it is good for the plant, good for you. Getting my point? Means mean time to repair should be less and mean time to failure should be large. समझ में आ गया? फेलियर आने का जो टाइम है ज्यादा होना चाहिए और उसको ठीक होने का टाइम कम होना चाहिए. समझ में आ रहा है सबको? हाँ जी सर. Everything is written in your book also. Now see, one more timing is there, that is called as mean time between failure. Means from one failure to another failure, how much time it is taking. That time interval they are asking. So very simple. What you have to do? Total device hours. Means what is the device hour? Suppose 4000 hours is the lifetime of device, divided by number of failure. So you will able to calculate what is the time between two failure, correct? Okay, time period what you can say. So total hours divided by number of failure, correct? Okay, then one more thing is there. Tell me one thing. What is lambda? Sir, lambda is number of failures, हाँ जी बिल्कुल, divided by time. Okay, what is mean time between failure? Sir, time divided by number of failure. So what is relation between these two? Sir, mean time between failure is actually equal to 1 by lambda. Simple. So if lambda is given in a problem and they are asking for mean time between failure, then simply do 1 by lambda. Answer. Right, everybody? Okay. One more thing is there. What is that? Mean time between failure is equal to mean time to failure plus mean time to repair. How, sir? How we can conclude this, sir? Because this thing is given in your book also, right? So you can mark in your book, don't write it. Sir, how this relation came, sir? So I am explaining that. See here, right? See here. Actually, suppose this is time t is equal to 0. Yes, sir. Here suppose this is the first failure F1. Failure F1. Then again, of course, some time it will take. Na? I am taking it mean time to repair, to restore it. Then after restoring it, correct, failure, repair, R for repair, right? Again, suppose after some time second failure is there. And then so on it is going on. See, I'm relating what is mean time between failure is equal to mean time to failure plus mean time to repair, this relation, and that is equal to 1 by lambda, correct? So now the point is how this come, correct? Suppose this is time t is equal to 0. From here customer suppose has started, assume it. So now first failure is coming here, F1. Then of course some mean time to repair is there, na? Correct? To restore it, yes. And then again suppose this is the second failure, and so on it is going on. So the point is, what is mean time between failure? Some mean time between failure is time between two failure. Yes or no? Yes, this is mean time between failure. Okay, so mean time between failure is actually mean time to repair, and after repair work only next failure is coming, na? If you have not done repair work, then how failure will come? Yes, so this is your mean time to failure. Yes, sir. On an average? Yes, sir. So from this relation what we can see, mean time between failure is sum of these two. Yes or no? Yes, sir. So the point is if in a numerical they are asking something related to this, then you can calculate by this formula. Sometimes what they do, they can ignore mean time to repair, correct? So I am writing here, if mean time to repair, correct, is not given, फिर से लिखना होगा यार. Okay, no problem. I will write again. So first of all, I am putting a boundary so that I will not cross that boundary. If I am crossing, na, then they will. Okay. Now see, mean time between failure is equal to mean time to failure plus mean time to repair, and that is equal to 1 by lambda. Okay. So this relation I want to show here. Suppose this is time t is equal to 0 for customer. This is first failure. Then suppose this is mean time to repair, and again after mean time to repair, suppose again there is another failure, and so on, correct? So the point is, this timing is on an average time to failure, because after repair work only failure will come. Yes, so this total time is called as mean time between failure, because time between one failure to another failure, right? So mean time between failure is equal to this plus this, right? And I was showing here, right, if mean time to repair, correct, is not given, so in that case mean time between failure is equal to mean time to failure, right, is equal to 1 by lambda. Simply you can put this also, correct, no need to confuse, right? So please write down this thing in on your book only you can write. This relation is given already. If you have any confusion, that is why I have explained by drawing this, correct? And you can also write this, and then in book in the last question number 5, question number 10 you can solve. Just apply this concept and solve it right now only. Solve it. Yes, right. Very nice. So I hope you have solved it. Simple, e power minus lambda t. Lambda is given, you need to just apply 1 by lambda and all, correct? And if mean time to failure is calculated, again 1 by lambda, mean time to repair is not given, right? So solution is also given. बच्चों वाला क्वेश्चन है, कुछ है नहीं इसमें. I hope everybody done. Right, now see, so in this way what we have seen how to calculate, right, mean time to failure, mean time between failure, right, what is relation between lambda and mean time between failure and all, right. Then now come to the reliability improvement, because in FMEA, failure mode effect analysis, what we need to do, we need to improve the reliability, right. So here 3 cases are there. Again this is mentioned in your book, no need to write, just I am explaining once. See, the point is see, the first is, suppose when series connected elements are there, series connected, right? Series connected means already you know what is series connection, like this. Means after one, suppose this is input, one by one it is going into, correct? Suppose its reliability is R1 and its reliability is R2. So what is formula of series connected? So reliability and efficiency also, right? If it is in series connection, you can simply multiply it, R1 into R2. And so many are there, just you can multiply all, right? So I am giving you one point. Suppose its reliability is 0.9 and its reliability is 0.1. Suppose. So what is the system reliability? 0.9 into 0.1. What is it? 0.09. Yes or no? Yes. So now my dear student, the reliability of the system is 0.09, correct? That is what we can see, even less than the lesser one, correct? It is having small reliability, na? Very less reliability, yes. So when they are connected in series, so overall system reliability will depend upon the smaller one. So can I write that is less than equal to reliability of the smaller one? Yes, correct. So the system, this is reliability of the system. This is reliability of the system. So in series connection, this is less than equal to a smaller one. Sir, when there will be equal to sign, sir? If suppose its reliability is 1, then simple 1 into 0.1, right? Then it will be equal to, yes or no? Yes. So now suppose I am giving you the point ki we need to improve reliability of this element, because if I will not improve reliability of this element, then overall system reliability has reduced. See, 0.09, that is very less. Yes. So sir, what we have to do? So what you have to do, simply suppose this was your R2 0.01, simply in parallel connect any element which is having higher reliability, suppose 0.8. First of all, how you can get ki sir in parallel reliability will increase, sir? How you are getting in parallel reliability will increase? See, I am giving you an example. In house appliances also, this tube light, the fan, AC, everything is connected in parallel, na? Yes. Why? Because suppose one is not working, then other will work. And suppose these all are in series, then if one is not working, no one will work. So even Delhi metro is highly reliable. Still, even metro is there, but still auto is running, cab is there, Ola, Uber and all. Then means parallel there are many transportation system is also available, so that the reliability will increase. So whenever we connect things in parallel, of course reliability will increase. Mathematically now we will see what is the formula. So for parallel connection, the formula is 1 minus R1, 1 minus R2, like that. And if more are there, you can multiply like that, right? So just apply this formula here also. What is reliability of the system? What is reliability of the system? So reliability of the system is nothing but 1 minus 0.1, 1 minus 0.8, correct? So overall how much it is? कितना आ रहा है बताइए? So this will be 1 minus 0.9 into 0.2 na? Yes. So 1 minus 0.18, yes. So 0.82 na? 0.82. So see, the reliability of the system is even greater than the larger value, yes or no? So in parallel connection, what we can conclude, reliability of the system is greater than equal to reliability of the larger value, correct? Larger value, individual larger value, correct? So in parallel it is more than this, in series it is less than this. Getting my point? Yes sir. So these things are there in your book also. Still you want to write in book only, you can write, or in notes also you can write. Please write down fastly if you are interested to write. Okay, done everybody? ठीक है. So mostly chances of these two cases will be more, but still one more case is there, right? And that is called as suppose your third case, and third case is called as standby mode. Standby mode means suppose there is a function at your home, correct, in your home, then you are already using one generator, that is sufficient also, but still what you do, you keep one extra generator. So suppose in any case that generator running generator is having any problem, then you can connect the extra one. So that is called as standby mode. Means the diagram will be like this. This extra one means input output is there, so this is a standby mode, correct. It may be more than one also, like that. So this is neither series nor parallel, this is a standby mode. Sir, what is formula? Formula is given in your book also, right? So just memorize those formula, correct. So these three cases they may ask in the examination, right. Now the reliability improvement also has been done. So before moving to maintenance and all, one question from my side, correct. Through this question I want to give you few more points. This is mains question, but you can have good idea of concept. But do one thing, anyway, see, tomorrow my class is there. Yes sir. So better I am just holding this class here only, correct today. So now you can leave the class. Tomorrow from here I will start, correct. So tomorrow timing will be from 9 a.m. correct, 9 a.m. to finish, or of course 12 a.m. of course we are going to finish, but from 9 a.m. tomorrow we will start, correct, 9 a.m. correct. चलिए तब तक क्या करो आप, थोड़ा सा अभी just before 12 I am giving you time na, so just solve all the problems whatever there in the back side of the chapters, right. See the problems, see the questions, how they are asking, correct. So today I am holding this class here only. Tomorrow from 9 a.m. my class will be there, right. Thank you so much.